Dear students, today I want to discuss the JEE Main 2020 that happened on 9th January, Shift 1. If you go through the physics questions, you can evident one factor, even one questions, or we can wait from each chapters. So you have to give importance to every topic. Look, the question number 1. The aperture, the diameter of a telescope that is given as 5 meter. So that is A that is given as 5 meter. The separation between the moon and the earth that is given as 4 into 10 raised to 5 meter kilometer. So we can say as 4 into 10 raised to 8 meter. With the light of wavelength lambda 5893 Armstrong, with the minimum separation between the objects on the surface of moon so that their just result is close to. So here, for a telescope, that resolving limit is expressed in terms of angle. So that resolving limit that is equal to 1.22 lambda, that division by A. And keep in mind the very important concept. Suppose the two objects. So here from observation, so we needed to find what is the separation between the two objects. So suppose it is represented as delta x, and it makes an angle, and that theta, that is called the resolving limit here. And suppose if we apply the concept angle is equal to arc by radius, that resolving limit we can represent it as delta x by L. Therefore, the delta x we can find to be equal to 1.22 lambda L, that division by A. So that is equal to 1.22 into 5.893 into 10 raised to minus 7. The wavelength into the separation between the telescope and the two objects as L as 4 into 10 raised to 8 meter by the aperture as 5. So if you just find the value, you get approximately as 57.51. So that is nothing but approximately 60 meter, and you get the answer as a 2. So this is a very important concept, and here the resolving limit is expressed in terms of angle. But for compound microscope, keep in mind, and that resolving limit is expressed as L distance, and is given as 1.22 lambda division by 2 mu sine theta. Keep in mind, there also that 2 mu sine theta is the aperture of the objective of the lens. So we can move to the question number 2. A good question is waiting. Consider a sphere of radius capital R which carries a uniform charge of density rho. If a sphere of radius r by 2 is carved out of it, then the ratio EA by EB of magnitude of electric field EA and EB at points A and B due to the remaining portion is. And suppose we consider the point as A here, the point as B. So the given charge is distributed on this remaining part only. But we can consider this sphere as like this one, a whole sphere. So it is uniformly charged one with the rho value. And we can say it is with a radius as r. got the volume charge density as rho. But if you add another sphere having radius as r by 2, but with the density as minus rho, if we add it together, then we get the concept of this one. So it is a very important concept. So with the introduction of negative rho, it is equivalent to the removal of that part from the solid sphere. Because of the introduction of that concept, we can easily solve the problem. So our aim is to find at first what is the electric field at this point. So we know there are two contributions. So if we consider the electric field at the point A, one, the electric field due to the whole value. You know, at the center its contribution is 0 plus. What is the contribution due to this one? But the point under consideration is on this point. So we can find what is the contribution of this sphere on its surface. The value is so simple, k into the charge on that small sphere division by its radius square. So r by 2 square. So that is equal to k into as 1 by 4 pi epsilon 0 into, because of the negative charge, as minus into, you know, the density is charge by volume. So charge is equal to rho into volume as 4 by 3 pi into r by 2 the whole cube. That division by r by 2 square. So you can cancel that r by 2 square. So remaining r by 2. So 4 pi cancel. So you get the value as minus rho r division by 3 into 2 as a 6 epsilon 0. So keep in mind what is the direction of electric field. But this is the electric field, but the negative charge here. We can conclude like this one. The whole of its negative charge is concentrated at this point. Then if we put a positive test charge at this point A, we need to find, then it is attracted towards that. So that is the meaning of negative. And keep in mind the direction is in the upward direction. So the second case is, what is the electric field at the point B? At first we can find what is the electric field at the point B due to the whole one. So that is equal to, it is simple as a k into the total charge as rho into 4 by 3 pi r cube, the division by its r square. Then what is the contribution of this one? But at this point, we can consider the whole negative charge is concentrated at this one, at the center. And hence we can say all negative charge at this point. So that point B is at a separation. This is r by 2 and this is r. So r plus r by 2 gap. The electric field at that distance can be subtracted from it because of the negative charge. So that is equal to k into the density into that volume as 4 by 3 pi r by 2 the whole cube by That separation, if you consider that negative charge as a point 1, then it is located as r plus r by 2. So that much q square. So we can take the common factor as a k into rho into as a 4 by 3 pi r cube into, so 1 by r square minus, so minus equal to, keep in mind is equal to this one as a 3 r square by 4. So 3 square, 9 r square by 4. Then 2 cube become 8 into 3. So equal to, so we take the value as a 4 by 3 pi r cube outside. So equal to, here it becomes 2 plus 1, 3 r square. So 9 r square by 4. So it is on the numerator. Then here 2 cube. So 2 cube become 8. 8 into 3 as a 24. So equal to, the k is what, as 1 by 4 by epsilon 0 into rho into 4 by 3 pi r cube. You can take that 1 by r square outside. On solving, you get the value as a 17 by 18. So 4 by pi r square. So in net value, you get the value as equal to 17 rho r division by 54 epsilon 0. But our question is this one. How we can find the value of the modulus of A by EB? That is equal to rho r by 6 epsilon 0. 17 rho r by 54 epsilon 0. Then after solving, you get the value as 18 by 34. A good question. So this is a very good theory part to keep in mind. How we can consider that removed concept by the introduction of negative charge density. It is a very good question. Keep in mind. Number 3. The electric field of two plane electromagnetic waves in vacuum is given as E1 equal to E0 cos omega t minus kx j, and E2 is equal to E0 cos omega t minus ky k cap. At t is equal to 0, a particle of charge q is at origin with a velocity v equal to 0.8 cj. Then the instantaneous force experienced by a particle. While considering this concept, you keep in mind one thing. Here the electromagnetic wave. So the presence of electric and the magnetic fields are there. So we have to consider so clearly. So at first, see here, we can consider the value as E1. So that is given as is equal to E0 cos omega t minus kx into j cap. So here it is moves along plus x direction, Then the propagation can be easily find out the concept as the A cross B will give the direction. It should be in our mind. Therefore, we can say the magnetic field is in k cap. That is a very important concept. Then how we can represent the corresponding magnetic field? So B1 equal to B0. We can find, E0 is equal to C times of B0. So B0 is nothing but equal to E0 division by C into, the argument got the same value as that of electric field. So cos omega t minus kx, and the direction, as a k cap. And similarly, it is given as the value of E2, that is equal to E0 cos omega t minus ky into the direction as a k cap. That means it propagates along the direction of plus y. And again, by using the concept of E cross B will give the direction. And by that we can find the value of B2. So that is equal to its B0 value. So E0 by C into cos omega t minus ky. The argument remains the same as that of the electric field into I cap. That is very important concept. Then we have to find what is the instantaneous force experienced by a particle. Here the both electric and the magnetic forces are there. So the Lorentz force is taken into consideration. So the charge Q is, so the net electric concept plus net magnetic concept together. So the electric concept, how we can find it? So simply, the electric field as Q, the charge into the net electric field. So E1 plus E2. And similarly, the magnetic contribution, the charge into the velocity here as a 0.8 c j cap into the net magnetic field, we can say as B1 plus B2. A good concept here. And keep in mind here that E1, we can say easily the direction only we can represent as E1, that take the value as E0j, and E2 that is equal to E0k, and similarly B1 that is equal to E0 by C into k cap, and B2 that is equal to E0 by C into I cap. So that is equal to, we can easily find this value as a Q, E0 in common, that much into J plus K, good, plus Q into 0.8 C, J into B1, the direction is K cap, B2, as a, keep in mind its direction. Point 8 Q E0 K cap plus I. So that is equal to Q E0 into J plus K plus, so this is a J cross K plus I. So just crossing that one. So 0.8 QC into, that is a very important concept. So E0, so here it is B1 plus B2. So we can take that B0 value outside. So that is E0 by Z. So C cancel. So we get the value 0.8 Q E0 into J cross K. You know the value as I. And J cross I, you know the value as M minus K cap. So that is equal to Q E0 into, you just take these two together, and then you get the value as 0.8 I plus J plus 0.2 K. A good question from electromagnetic wave. A good question. So comfortably keep in mind, we have to apply this concept, the Lorentz force, the electric and the magnetic force together. So that is a good question. Number 4. A body A of mass m is moving in a circular orbit of radius r about a planet. Another body of B of mass m by 2 collides with the A with a velocity which is half v by 2. The instantaneous velocity of A is. So you can just, because of the collision, it is given, it is completely inelastic. That means after collision they combine together. Then what happened to the combined body? So it is given, it falls vertically downward. It moves with an elliptical orbit, continues to move in the orbit, escape from the planet's gravitational field. At first, for this inelastic collision, we can apply the conservation of linear momentum. So for that m by 2 mass body, that is moves with a velocity of v by 2 plus that m will move with a velocity v is equal to that after collision they will combined move with a velocity as vf. So we can take that m into v as a common, that into 1 by 4 plus 1 equal to 3 by 2 am into vf. So here m cancel. So v into as 5 by 4 is equal to 3 by 2 into vf. So you get the value for vf is equal to as 5 by 3 times of v. So the final value is 5 by 6. 5 by 6 times v. So if we just considering the initial value, the final value is less compared to the initial. So it never escape from the planet's gravitational field. Never move along the same concept. And keep in mind, because of the less value, the combined mass, will go to the elliptical orbit. A good concept, the very important concept. So we can say the 2 as the answer. Number 5. Which of the following is an equivalent cyclic process corresponding to the thermodynamic cyclic given in the figure, where 1, 2 is adiabatic? Look the curve once again. So this is the curve, the given. So that is a P versus V curve. And here, and that starts from 1, then towards 2, then towards 3, then towards 1. So we have to analyze which is the volume temperature curve is correct one. So by using these informations we can attain, but it is just to go through this concept. 3:1 is volume constant. That means isochoric process. So 3:1 is isochoric process. If you just analyze through that, 3:1 is not the isochoric process here. So we can think the second choice is wrong. So that is not correct. Then keep in mind, from 2 to 3, if you just consider as 2 to 3, while considering 2 to 3, it is given as isobaric process. So that means V proportional to temperature. So here the volume from 2 to 3, its volume decreases, and surely we can say the temperature should decrease. So that is a very important concept. And also, one concept is there. So because oleum decreases T temperature, that means choices 3 or 4 we can take the correct concept. But it is also given as 1 to 2 is adiabatic, and hence this is not possible, and you get the answer as 4. So if we just analyze the figure, we get the answer. Number 6. A good question, but multiple concepts should be with you. Two particles of equal mass m have respective initial velocities ui and u by 2 into I plus j. They collide completely inelastic. So they combined after collision. The energy loss in the process. So simple steps are waiting. So at first, see that m mass, a small m mass is there, and is moves with a velocity u, and is collide with another one. Say again, it got the same mass as m, but it got the two velocities, one along I, so that is we can say as u by 2, another along y, so that is again it is u by 2. So we can they are collide completely. So after collision, that become 2m mass. The energy lost, we have to find it. So at first we can just conserve the case for x direction. So for x direction, it is simply as em into u plus, so that is m into u by 2. Then after collision, the combined one 2m, that with God and x velocity, say vx dash. It got a velocity as vx dash. So you just cancel that m value. So 2 plus 1 as 3 by 2 u. It should be equal to 2 into vx dash. So we get the value as vx dash is equal to 3 by 4 u. A good concept. And similarly, if you just consider for the conservation of momentum along the y direction. So along the y direction, there is one concept, that is m into u by 2. That should be equal to, suppose it is with the y concept as vy dash, and we can say that m into u by 2 equal to 2m into that vy dash. So there mm cancel, and you get the value as vy dash is equal to u by 4. Good. So now we get the two velocities after collision, the x velocity and y velocities together. Then we can easily find what is the kinetic energy initial. So that is equal to, this is the 3 cases we have to account. So what is the kinetic energy for m? That is simply as a half m into u square. Then plus, what is the contribution? We can say consider the x contribution. So that is equal to half am into, yes, u by 2 square, plus what is the vertical contribution as u by 2 square. So that is equal to half em into u square plus 1 by 4 em into u square. So equal to 3 by 4 am into u square. Then we can find what is the final kinetic energy. So the two objects combined together move with the 2m. So we can say that half into 2m, but it got the two velocities. So at first we can consider that vx value. So that is equal to 3 by 4 u square plus what is the contribution for the vertical components. So that is equal to u by 4 square. So by solving, you get the value as mu square into 5 by 8. Our aim is to find what is the loss of kinetic energy. So that is equal to m into u square into 3 by 4 minus 5 by 8. So we can take this one as a 6 by 8. 3 by 4 as a 6 by 8. Then the answer becomes so simple that m into u square by 8. So that is the answer. A good question, good concept. Number 7. 3 harmonic waves having equal frequency nu and the same intensity I0 have a phase angles 0, pi by 4 and to minus pi by 4. When they are superimposed, the intensity of the resultant wave is class 2. So it is so simple. Suppose it is in connection with the amplitude. You know that I is proportional to amplitude square. And suppose here the 3 waves are there. We can just plot that 3 waves as say, and this is one wave as A. Then the another makes an angle of plus pi by 4. So we can say this is the another wave with A amplitude with the angle of orientation of plus pi by 4. And the third one, with respect to this A, it is with another pi by 4, but got the same amplitude. So both that 3 waves got the same amplitude. Then at first we can just think about what is the resultant of these 1 and 3. 1 and 3, they make an angle of 90 degree, and hence their resultant should be what? So here 1 and 3, they got the amplitude as A, but both got the 90 degree. So you can use the simple formula that is equal to root of A square plus B square plus 2AB cos 90. So 90 factor becomes 0. So you get the value as a root 2A. You know, they got the same amplitude and hence it must move parallel diagonally but at equal separation, and hence it got the same direction as that of the second one. So the second one already got the amplitude as A. Therefore the net value between 1, 3 and 2 become root 2A plus A. So we get the value as a root 2 plus 1 into A. So that is the resultant amplitude. But our aim is to find what is the resultant intensity. So that is equal to root 2 plus 1 square A square. You can consider that root 2 plus 1 as A plus B the whole square is equal to A square. So root 2 square, that is 2 plus B square plus 2 root 2 into 1 into A square as I0. So 2 plus 1 as 3 plus 2 root 2 times I0. So that is the answer. So by solving it, you get the value is equal to 3 plus 2 into 1.41 into I0. You get the answer as 5.8 I0. It's a good concept, good concept. Next one, number 8. Water flows in a horizontal tube. See the figure. The pressure of water changes by 700 Newton per meter square between A and B, where the area of cross section are 40 centimeter square and 20 centimeter square. Find the rate of flow of water through the tube. So that is, we need to find it. So at first, we can just use our equation of continuity at the points at the cross sections A and B. We can say that 40 area of cross section say moves with the velocity VA equal to the area there as 20 into VB. So we can say that 2VA take the value equal to VB. It's a good concept there. Then at the 2 points we can apply the Bernoulli's principle, maybe the very, very important concept. So at the same horizontal level, we can avoid the potential energy contribution. Then the pressure at the point A plus half rho VA square should equal to, for the B concept, PB plus half rho into VB square. So we can say as PA minus PB, take the value equal to half rho into VB square minus VA square. So the change in pressure P is equal to, that is equal to half rho into as VB square minus, we can say that VA as VB by 2. So VB square by 4. Then you get the value equal to half rho into 3 by 4 VB square. From that relation you get the value for VB. That VB is equal to root of VB is equal to root of, that is 8 into delta P division by 3 into VB square. So by putting the values, that is equal to root of delta P into 4 division by as 1500, that is equal to, as a delta P is given as 700 into 4 division by 1500, you get the value here as VB. But our aim is to find what is the rate of flow per second is equal to that area into velocity. So VB is here. So the area cross section of B, so that is equal to 20 into that we have to find the value for VB. Then you get the value is equal to, if you just that 20 into the VB as a root of as a 700 into 4 division by as 1500, and you get the value as 2732 centimeter cube by second. It is a very important concept. So you get the answer as 3 as the answer. And keep in mind, the Q is the quantity of water flowing per second. So that is area into velocity. It is a good concept. Number 9. The radiation with wavelength 6561 angstrom falls on a metal surface to produce photoelectrons. The electrons are made to enter a uniform magnetic field of 3 into 10 raised to minus 4 Tesla. If the radius of the largest circular path followed by the electron is 10 millimeter, the work function of the metal is closed to. So at first we can apply that photoelectric concept. You know there, the half mv square, half m into v square. So that is equal to h nu minus the work function. But we have to relate it with the movement of the charged particle in a magnetic field. So there we can say the concept as in a circular path, you know, the very important concept as mv square by r, the centripetal circular path, centripetal force is given by the magnetic force there. So v cancel. So mv by r equal to qb. So you can substitute here for mv as you just square by m. Then you can substitute for mv as qbr. You get the value as half into q square b square r square by m. That is equal to h nu by w0. And our aim is to find what is w0 equal to h nu minus half q square b square r square by m. But here the answers are in electron volt, and hence we have to divided it with the E. So simple substitution. So h into nu can be written as hc by lambda E. hc by lambda E. So h into c is, you got the value as 2 into 10 raised to minus 25 by The lambda as a 6.5, 6.1 Armstrong into U as 1.6 into 10 raised to minus 19 minus half into the 1e cancel. So charge as 1.6 into 10 raised to minus 19 into the magnetic field square as a 3 into 10 raised to minus 4 square into that radius as a 10 millimeter. So 10 millimeter, that is nothing but equal to 10 into 10 raised to minus 3. That much square. That division by 9.11 into 10 raised to minus 31. You get the value as 1.9 electron volt to minus 0.79 electron volt. And you get the value equal to 1.1 electron volt. So 3 as the answer. A good concept, good related concept between photoelectric effect and that movement of charged particle in a magnetic field. Number 10. A particle moving with kinetic energy has a de Broglie wavelength as lambda. If energy delta is added to this energy, the wavelength becomes lambda by 2. Then value of delta is a simple concept. You know, as lambda equal to h by p, we can substitute for p in terms of energy as 2m into e. But in the second case, this lambda become lambda by 2. That is equal to h by, as a root of that energy is increased to e plus delta e. So just dividing, you get the value as 2 is equal to root of e plus delta e, that division by e. So squaring, you get the value as 4 is equal to 1 plus delta e by e. So delta e by e equal to 4 minus 1 as 3. Therefore delta e, take the value as 3 and you get the value, the answer as 2. Number 11. A good question. A charged particle of mass m and charge q moving under the influence of the electric field E, that is along the I direction. That is along the I direction. And a uniform magnetic field B, K direction. That means along vertically upward. Follows a trajectory from P to Q as shown in the figure. From the P to Q, a circular path is the trajectory. Here it is enter with v velocity. Here it moves perpendicularly with 2v. Here the side is a and here it is 2a. The velocities at P and Q are vi and minus 2vj. Then which of the following statements are the correct? And here, the first one, what is the value of electric field? So we can just use the concept here. See, the very important concept. And for this one, what is the acceleration? So simply, you know the concept as, at first we can, the entry velocity as what? U. That is given as v. What is the final velocity? As a 2v. You know, the displacement occurs. It is a 2a at the end. So we can say, so what is the acceleration to the particle? Simply as v square by u square, that division by 2 into s. So that is equal to, you can substitute it for 2v. So 4v square minus v square by 2 into 2a. So we get the acceleration as 3v square by 4a. But you know the concept as the force is nothing but equal to m into a. That is nothing but equal to q into e. So you get the equation for E is equal to m into acceleration by q. That is equal to m into acceleration as a 3 v square division by 4a by q. So that is the concept. So 3 by 4 into mv square by q into a. So that is the correct concept. So a is here, the multiple answers are there, so we can wait. So the first choice is okay. And the second concept is the rate of work done by the electric field at P is 3 by 4 mv cube by A. So at the point P, so that is we have defined. At the point P, what is the rate of work done? So the rate of work done, that is nothing but equal to the power there. So that is equal to the force acting at that into the velocity there. So force is nothing but equal to mass into the acceleration into the velocity there. But we already, the acceleration of the charged particle is 3v square division by 4a into v. So that is equal to, simply we can say that 3 by 4 mv cube division by a. So that is the rate of work done. So that is also correct one. Then we can move to the third one. Third choice is, it is what? The rate of work done by both the field at Q is 0. At Q is 0. So that is the concept we have to see. At first we can just, what is the contribution from the electric field? So the electric field is at this point is acting in this way. And the movement is this one. The displacement got like this one. So what is the angle between them? Here the electric field is in this way. That means the force is acting in this way. So the force and the displacement got 90 degree. So the work done becomes 0. Then what is the contribution from magnetic field? So it is a circular path. So the work done is nothing but equal to the change in kinetic energy. So there is no change in kinetic energy because of the magnetic concept. And hence we can say the work done also 0. So that C choice is also correct one. But we have to think one more concept. The difference between the magnitude of angular momentum of the particle at the point P. The angular momentum at a particular point we can find it to be is equal to the linear momentum into the perpendicular separation between them. And keep in mind the direction, that is can be clockwise or anti-clockwise in the concept. So here at this point here the movement is clockwise, and hence there should be a negative sign is there. So we can find the what is the magnetic field contribution. Say at first we can just think about the final point here, that is mass into, so the movement is clockwise, so the minus the linear momentum is m into the velocity there as 2v into the perpendicular separation between the line of action and the axis, that is equal to 2a. So that is a very important concept. And the next concept is what? What is the angular momentum at the point P? So this is the v direction. So we can say the change in angular momentum means minus. So the contribution again clockwise. So minus into mass into the velocity v into the perpendicular separation between the line of action and the axis as what? A. So mva. So keep in mind what is the direction to that. So that is a very important one. So perpendicular to the plane containing, and that both the perpendicular distance and the velocity. So it must be. So here that is R cross P. R cross P. So this is R and this is P. So we can say that it is downward. It is a very important concept. So here K direction, that is a direction. So that is equal to minus m into 2 into 2, 4 mva plus mva. So equal to minus 3 mva. Minus 3 mva. Then what is the direction? It is vertically downward. So that is a very important concept. So minus 3 mk cap. But it is not. So that's a wrong one. So we can take that A, B, C as the answer. A, B, C, 2 as the answer. It's a good concept. So please once again go through it, every aspect there, then you get become clearly. Number 12th one. If the screw gauge on is given 6 rotations, it moves by 3 millimeter on the main scale. That means we can easily find what is the pitch. The pitch is nothing but equal to the distance moved by that number of rotations. So that is a concept. So the distance moved is here the 3 millimeter, that division by 6 rotations. So you get the value for it as simply as a 0.5 mm. And it is given there are 50 divisions on the circular scale. So the least count is equal to least count, take the value is equal to pitch division by the number of circular scale divisions. So equal to 0.5 millimeter by 50. So 5 cancel. So you get the value as 0.01 millimeter. 4 equal to, so 0.001 centimeter. So you get the answer as 2. So some questions are lengthy, but if you know thoroughly the concept, you can get it, no doubt at all. So up to this one, and the next questions from 13 onwards, we can wait for the second video till question number 25. God bless you. Take care.